So today we're talking about combining like terms. And when you think about combining like terms, think of it in terms of if I threw pens and pencils and crayons all onto the floor in a pile, like how would you separate those? I mean, most likely, if I said separate them, you would think, okay, I'm going to put the crayons in one pile and the pencils in another pile and the pens in yet another pile. And I want you to kind of think of like terms in that same respect. If I have 7x squared, x cubed, 4, 2, 17x, 12x cubed, 3x squared. And I said, okay, here's this bundle of numbers. I want you to separate them, organize them somehow. And there's different ways you can go about it. You go, well, everything that has an X in it can be in one pile. But literally, the only thing that wouldn't be in that pile then would be the 4 and the 2, right? When we talk about combining like terms, right, what we're saying is that anything with an X third, X to the third power. So one combination could be X cubed and 12x cubed. The next set of like terms would be like 7x squared, x squared. Then we have a 3x squared. Our x's, just solo x's, right? We've got x and 17x. And then anything without, say, an x value would be its own like term. And when we're talking about like terms, that's what we mean by combining them. I can combine x cubed and 12x cubed, right? I can add and subtract them to each other. And really that's what we're talking about, is being able to add and subtract them when we're talking about polynomials, right? So there are different parts of an expression. In the last lesson, we were talking about expressions and we were evaluating them by plugging things in for the variable. Today, we're going to talk about the different parts of an expression. So if I have, for example, let's do it in a different color so it doesn't get blended with what we just did. If I have 7x plus 3 minus 5x plus 8 plus 4x minus 1. If I want to talk about the different parts of this expression, right? If I take this whole thing right here and I want to talk about the different parts of it, right? First of all, we're going to have variable terms, right? Variable terms. Variable terms are anything that has a variable attached to it, an X, a Y, a Z, an A, a B, something that is substituting in for a number. So in this case, our variable terms would be 7x, negative 5x, 4x. These are all our variable terms. They are the terms with variables, right? The numbers that are attached to these variables are what we call coefficients, right? So our coefficients are the 7, the negative 5, and the 4, right? 7, negative 5, 4. They're just whatever number is attached to our variable, right? On the other side, we have the non-variable terms and we call those constant terms. Anytime we don't have a variable, anytime it's just a number, we just call them constants. So you'll hear that expression a lot, and all it means is they are those numbers that don't have any variable, any letter attached to it, right? And in this case, we've got 3, 8, and negative 1. And that's really all of the parts we have of an expression, right? Because all an expression really is things being added and subtracted from each other, right? When we're talking about combining like terms, it's really adding and subtracting that we're talking about, because multiplying and dividing we can do with terms that aren't alike, but we cannot add or subtract terms that aren't alike. And that's how we get these crazy polynomials like we saw up here. So when we want to combine like terms, combining like terms, what we're really doing is we're simplifying these algebraic expressions by putting things that are alike together, right? So it means that we can combine like variable terms. And that's kind of what I was showing you in the beginning, where I had all those different terms and we talked about, well, how do we bunch those together? If we took that same expression that we had up above, that 7x plus 3 minus 5x plus 8 plus 4x minus 1, right? And we want to know what that equals. Well, what we're going to do is we're going to take our like terms and we're going to put them together. They can be added and subtracted from each other. So if I looked at this, I'd go, okay, well, anything that is just an x, I don't have anything with variables on it. So anything that's just an x, this 7x, this 5x, this 4x, they can be combined together. So I can go 7x minus 5x, well, that's 2x. 2x plus 4x is 6x. And so I know that my x values are going to equal 6x. Again, all I have left now are constants, right? I don't have any different powers or anything like that. So I'm just going to go, okay, well, now I just have my constants to deal with. So I can go, well, I have positive 3 plus 8. Well, that's 11. Minus 1 is 10. So I have 6x plus 10. And so I've combined the like terms to simplify this expression. What was all of this jumble can more simply be written as 6x plus 10. And that's all we're talking about with combining like terms, right? It's simplifying expressions. So we'll just do a bunch of examples of that, and you'll have a Delta Math assignment, but that's literally all we're kind of trying to do in this video, really, is to simplify different expressions. And we'll do a couple like this, and then we'll do a couple where they have different powers and how we combine those. But you'll see it's all basically pretty simple. So we'll start with the first example. If I have 3x plus 6x, both of those are x terms. We can just combine them to equal 9x. If I have 7m minus 5m minus 6, I can combine my m terms. I can go 7m minus 5m. Well, that's just 2m. And then I don't have anything to combine that negative 6 to, but we can just bring it in as minus 6. And we've made that 3-part problem a 2-part problem. What if I have, for example, 7p minus 1 minus 9p plus 5. When I have that, I can do the same thing, right? I can go, okay, well, I have a p here, 7p, and I have minus 9p. 7 minus 9 is negative 2p. So we've played those out, right? We've used the p's. So now we're going to come over to our constants, and we're going to go, well, we've got minus 1 plus 5. Well, that becomes plus 4. Right? And that's really all there is to simplifying these types of problems. You're going to have one to solve here on your own for just a second. And then when we come back from solving that, we are going to move on to combining like terms with powers, with exponents. Okay. When we're dealing with exponents, it doesn't really change matters much, right? If I have exponents, any base value, so if I had a base value of x and say it was squared, it could combine with anything else that is x squared. So if I have x squared plus 3x squared minus 2x squared, these all combine together. X squared plus 3x squared is 4x squared minus 2x squared is 2x squared. As long as they have the same base and the same power, they can be combined, right? I cannot combine x squared plus y squared because the bases aren't the same, right? It doesn't work. So what does that look like in terms of examples? Well, if I have 5x squared plus 7x squared, I can combine those two to get 12x squared. And we can mix these things up a little bit, right? What if I had, for example, 8x squared minus x minus 5x plus 7 minus 2x squared. When I look at this to solve it, it still works the same way. There's multiple facets in here, but we're still going to combine just our like terms. I'm going to start with anything that's squared because that's my highest power. I'm going to take all my x squareds and I'm going to combine them. Well, I have 8x squared minus 2x squared. That is 6x squared. And then I'm going to move on to the next. I'm going to go, okay, well, what about my x's? I have minus x minus 5x. That's going to be minus 6x. And last, I just have my constants, my numbers. And the only place I have one of those is right here. So I'm just going to go plus 7. And that's about as complicated as it gets when we're combining like terms. I am going to give you an example problem to do at the end of this ed puzzle right now. All right, I hope everybody got that right. You'll have an assignment in Delta Math. That's it for this ed puzzle. It should not be too difficult. Don't forget there will be another one for this week, so keep an eye on PowerSchool for that. And I hope you have a good day.